Okay, that's enough of that. Oh, I see my webcam is going to not work today either, even though I just restarted everything so that would work. Anyway, that's okay. I thought I'd start today off just going over the test two guide. So I posted this last night, but I didn't announce it. So um, I'll talk about this now. So test two is next Friday, and uh, a little bit more points than the first one, but same general idea as the first one. So this covers propositional logic and truth conditional meaning of sentences with like one small thing from predicate logic, just because by the time we do this test, we'll be done with that seventh lecture. So there's four things you have to do, and I've given about rough time estimates here, but of course you have that extra time after if you need it. So the first question is to translate English sentences into well-formed formulas. So there will be four sentences. One of the sentences will be ambiguous, so just like the assignment, but I provide keys. So you don't have to think about what the subjects and predicates are. You don't have to spend time writing out what the keys are. Um, those are things that I will provide for you. Is the quality bad on my end, or is it just super zoomed in? Someone please answer that question so that way I know as well.
It's better now.
It is better now. Okay. Okay. Quality is fine. That's good. That's good. Might be an internet thing then. Okay. Question two. There will be one truth table for entailment. So I'll give you a well-formed formula, like in the exercise or on the, what was it? In the truth table question on assignment three, I asked you if A arrow or A and B arrow B and A was a tautology, a contradiction, or a contingent well-formed formula. So this was actually an entailment question in disguise, but you didn't know that at the time. Or, well, maybe you did since you learned about it when you did it. But this was basically asking, does A and B entail B and A? And if you found this was a tautology, then yeah, it did. So um, you'll get well-formed formulas that are similar to this. They're not going to be complex. So you'll just have to fill out the truth table and then say whether or not they entail each other. So I'm going to provide you with most of the truth table as well. So I would give you A, B, I'd fill out the rows for you. I'd give you A and B, but I might not give you that final column or final two columns, just to make sure that because you're looking at entailment, you know how to set up that final column or two for entailment, and you know how to interpret what entailment means. But for the sake of time, I'm providing you with most of the truth table. The third part is probably the longest part. It's a compositional semantics tree. So you'll be given a sentence just like question one on your current assignment, and you'll have to draw um, well, you won't have to draw the tree. I will give you the structure. So I will draw the sentence out for you with the nodes and I will label them. You'll just have to give the rule and value for each node. And you'll have a choice. So you can either redraw the tree if you want and do the labels right on the tree, or you can just do it in list notation like on the lecture page. So if you go to, um, where is it? If you go to modules in lecture 6 and you take a look at how this tree is done at the bottom, basically I am providing you with something like this. I am providing you with the structure, and then you could just fill it out like this if you want. So that might save you some time as well. But if you want to do it on the tree, you can. So that is the majority of the points on the third test. And there's nothing new in that tree. As long as you can do the trees on the assignment, the ones in the lecture notes, and also the little extra practice here, you should be totally fine. You're not doing any new rules. So if you haven't done these two as well, I'd check these out if you still want some more to practice with. If you're confident with the ones on the assignment and the ones in lecture, then maybe you don't have to do these, but they're here for practice. So Charlie likes Martha, and it is not the case that Fido is Brown. Oh, this looks familiar. And it is not the case that Solomon knows David, and there's full trees typed out here. For A, does the order matter? In that practice sheet. You mean for like Charlie likes Martha, and it is not the case that Fido is Brown? Like which one you do first? In the tree structure it matters, but when you do node by node in like in the answers, Fido is Brown appears on the leftmost. Does it? It does. It does appear on the leftmost. Okay, so the sentence here is different than the sentence on the sheet. I will change this. Yeah, Fido is Brown. It is not the case that Charlie likes Martha. Okay, yeah, that needs to be changed. So the sentence up here should say Fido is Brown, and it is not the case that Charlie likes Martha. I mean, really nothing is changing except for the meanings of these two clauses, but the structure is still the same. So I will update this sheet. Thank you for pointing that out. It's amazing. I've used that for 2 semesters and no one has said anything. So thank you for being the first. Okay. The second part of that is I'll give you some information in a situation, and then you'll say whether or not it's true or false for that situation. So this is very similar to question 2 in assignment 4 that you're doing right now. But it'll be a very, very short one, since you'll only have like 2 little sentences you're looking at in the composition tree. So I can only give you like 2 small facts about the world. So this is really just testing whether you can convert the set notation for verbs to the truth notation for sentences. And this is the point difference is quite staggering, just because the trees are so big and the truth value is so small. And then for predicate logic well formed formulas, I'm just going to give you 2, and you just have to tell me whether it's well formed or not. So questions 1, 2, and 3 are file upload questions. So you can draw them out by hand and then upload them. Question 4 is a drop-down menu. So it'll just say yes or no on the canvas itself, and you can put them in as yes or no. Or if you're submitting it later, you can just type it out in the email or include it in a file when you email that. So however you answer it, if you don't answer it in time on Canvas, you can submit it over email. So there's no lecture that day because the test is going to take up the entire Friday. So I'll just be in Zoom during the live class anyway. In fact, I'll be there 10 minutes early at 10:20. Just so I'm there a whole hour. So you can take the test during that time if you want. So I'm there to answer questions. But if you're going to take it anytime throughout the day, there's no lecture that day. So just do it whenever you want, and I'll be monitoring my email as much as I can. I'm also extending the deadline for late submissions up to an hour with no penalty instead of 45 minutes, just because people were submitting it like 46, 47 minutes late, 49 minutes late the first time, and I didn't want to cap people's scores out at 80% for being like 2 minutes late. It seemed pretty arbitrary to say, oh, it's 47 minutes late, you can only get 80%, so we'll just do an hour. And if it's an hour and 1 minute late, I'll probably still not give any penalty, because being 1 or 2 minutes late is whatever. Just once you're at the 1 hour and 10 minute, 1 hour 5 minute range, then you're making things a little bit more difficult for me. So just try to do it within an hour.
The time limit for the exam is 60 minutes.
Yes. Yeah, 1 hour. So a rough pacing here to make sure that you can do everything and have time to check your work. So I've tried to, like I said, in all the questions, give you as much information and stuff pre-written out for you as possible, so that way you can just focus on the concepts and not so much with writing. So, with compositional semantics as well, I'm also going to try to give you like A, B, C, D, E, F, G, where I have all of the nodes written out. So if you want, you can also just write like A rule value, B rule value, and I'll know what those mean to save you time. Um, that's why with the truth table as well, I'm going to give you most of the columns. So that way you don't have to write out the columns again on your sheet. You can just write like 1000 or 1001, and I'll know how those correspond based on what I've given you. So I'm providing you time liberty so that way you can just focus on the content and or the concepts rather than focusing on all the other writing stuff. But if you need that extra time, do please take it. Are there any questions about test 2? And again, you can have all the materials available and open while you take it. Okay, I mean, if you do have any, they're still a week away, so email me or post on the discussion board, and I'm always happy to go into more detail. I don't think there was anything else that changed from the first test guide here other than the time change and the question content change. But yeah, it's these ones are no more difficult than the assignments. Very, very similar. Okay. So in that case, we can return back to some predicate logic translations. So what we did last time, and just to remind you, we finished by talking about the universal and existential translations. So the sentences were like, every puppy is cute and some carpenter is underpaid. We established that for the universal, we use the arrow, and for the existential, we use the conjunction symbol, and we showed why when we use the conjunction with the universal, we run into translation issues, and why when we use the conditional with the existential, we run into truth value issues with our translations. So now what we're doing today is we're going to do some practice with translations, but first we're going to take a look at negated quantifiers. And negated quantifiers can be difficult at first because you might be thinking like when we encounter things like no or not all, what does that mean in terms of some and every? But we'll talk about how we can think of those. So can have a translation of sentences like no cat is kind and not every clown is funny. And we can start with something like not every clown is funny. So I want to start with 14 just because this is a little bit more straightforward because it's quite literally not every clown is funny. And this one conceptually can be thought of a little bit differently than the translation. So I want to do this mechanically first, and we're going to find that there's actually 2 ways that we can translate these sentences. Okay. So not every clown is funny. So we can do this mechanically the same way as we did before. Not every clown. What we do is we consider not every to be like one quantifier. This looks like a negation not, but not every we consider to be a quantifier. So not every clown is a quantified phrase. So what we can do is we can extract it from the sentence. So we get like not every clown. We index this with X, and then we're left over with like this predicate, X is funny. Okay, so then when we translate this piece by piece, I mean, we can break up not every and clown, and then we can literally translate not and every as we would. So it is not the case that for every X, and then we can continue the translation as normal. So the reason I emphasize so much that the arrow is used with the universal quantifier is that even when we have these negated quantifiers here, like not for all X, we still maintain this translation rule. So it is not the case that for all X, if X is a clown, then X is funny. So not for all X, if X is a clown, then X is funny. So what this just means in some paraphrase, if we say not every clown is funny, what we're just saying here is that there's some clown that is not funny. So you can imagine that there's also going to be a second way that we can translate this sentence. And we're going to see how we can do this in a bit. But this is a paraphrase of that sentence. Or sorry, some clown is not funny. Okay, so again, we don't have to use the word every as well. We could also use a word like not all. So not all clowns are funny. Usually it's either not all or not every. So we can't really say not each clown is funny, or I mean, yeah, there's not really other ways in English to express it. Okay. No cat is kind. Let's actually think about this one conceptually. So if we have a set of cats and we have a set of things that are kind, well, if we say no cat is kind, basically, like there's no overlap here. So if we compare it to something like there is a kind cat, the original statement, like some cat is kind, we would say that there exists an X such that X is a cat and X is kind. You know, that's what we would say. There is some cat that is kind. But when we say no cat is kind, this is really the image that we're getting. Sorry, question in chat. So blue is the quantifiers, green is the noun, red is the verb phrase. Yeah, in these slides, this is how this works. I don't know if this consistency is maintained in every case, but this is what I tried to go for the basic translations. Okay, so for no cat is kind, basically we're saying that, you know, there's no overlap here. There's no overlap. So we can just take our translation of some cat is kind and then negate it. Like there's nothing there. There is no cat that is kind. There is no exists an X such that X is a cat and X is kind. So we can do the same mechanical procedure. We can say no cat is a quantified noun phrase, a quantified expression. We can pull it out. We can translate no as the negation and the quantifier. So no is the same as not some, or you can say not a single. Maybe that's a better way of thinking about no, if you can't quite remember that no is not exists. So not a single cat is kind would be another way of paraphrasing no cat. So there does not exist an X, such that X is a cat and X is kind. So in other words, there's no overlap here. Another way of paraphrasing this would be saying that every cat is not kind. So this would be an example of a paraphrase. So every single cat is not in that kind set. Every cat is not kind. So we'll also think of another way that we can translate this sentence. And that's what we'll show next, formally. But as far as these translations go with negating everything outside of the expression, are there any questions about this? And actually, I am just going to explain the not every clown is funny in a picture, just because I'm realizing that I'm not actually going to have the opportunity after. So if we think of this box as all the things that are funny, and we think of this circle as all the things that are clowns, if every clown was funny, then that entire thing and that entire circle would be in the set of funny things, because every clown would be funny. But when we say not every clown is funny, we're basically saying that there's something in that circle that is outside of that funny box. So not every clown is funny, saying not all X that is a clown is inside that funny box. But the reason I say there's a good paraphrase here as an example is that there's like this hidden box outside that is everything that is not funny. So it's almost like saying that there is a clown in that area that is also not funny. So, I mean, we can use the same picture for both circumstances. Okay, so I mean, let's actually work with that other translation. So here are the same translations that we just saw. So the ones on the previous slide are still here. So no cat is kind and not every clown is funny. These are the ones that we just did. So let me write the paraphrases for you. So no cat is kind. In fact, let me just draw the pictures here as well. So no cat is kind. Cat kind. This is this image. Not every clown is funny. Here's funny. Here's clown. So the idea is you have a clown here and you have a cat here. So these are the two images. So a paraphrase of no cat is kind is like saying every cat is not kind. So what I mean by this is everything outside of this kind circle are the things that are not kind. And what I really should be doing is I should be putting the cat. I should really be putting this red circle inside the cat box or inside the cat circle, because we are talking about cats. So the red circle should be in the cat circle because we are talking specifically about cats here. So when we think about where this individual is, this individual is a cat, and that individual is not kind. In fact, everything that is a cat, this entire circle is in the set of things that are not kind. And I should be really clear with this picture that it does not include everything that is kind here. So there's like a boundary here for this kind set. So this entire subset, it's like saying that if you're a cat, you're in the subset of things that are not kind. So like the kind complement set, but we can sort of abbreviate this and say not kind. So if we were to translate this, how we could translate this is we could say for all x, just using this subset picture here, if x is a cat, then it is not the case that x is kind. So for every x that is a cat, x is not kind. So all cats are not kind. And these two translations are equivalent translations. So these are not, these do not mean different things. These are just paraphrases of each other. They both mean exactly the same thing. They're just two ways of writing the same thing. No cat is kind means that every cat is not kind. So when you see a sentence like this, there are two ways of translating it, and both ways are acceptable. Okay, are there any questions about that one? Mechanically, you can do the same procedure. So every cat is not kind. You can take the expression and you can give it a value. And what you can do is you can take is not kind, and we can give it this predicate form. So every cat x is not kind. So we can just treat it as part of the predicate in this case. And then when we translate it piece by piece for all x, cat x, not kind, sorry, well, not becomes the negation symbol, kind becomes kind x, and then because we use the universal, we use the arrow. So mechanically, we can do the same thing. The process doesn't change. Okay, so for the case where we say not every clown is funny, the same sort of idea here. I'll get to the question just after this. So clown and funny. Not every clown is funny. The paraphrase here, if we say that not every clown is funny, we're saying that some clown is not funny. Because if not every clown is funny, that means that there's some clown out here who is not funny, who's outside of this funny box. So we could say there exists an x such that x is a clown. Because we use the existential, we're using and. Not is going to be treated as a negation, and then funny is going to be treated as funny x. So there exists an x such that x is a clown and not funny x. So x is not funny. So this is the mechanical way of doing things, just without showing the work there. But we could also think of this conceptually. So if there is this thing that is in clown and not funny, of course, we could say that there is some x in clown intersection funny complement, which is the same thing that there's an x in clown intersection not funny. and you could get that same translation. So on the test, will we need to provide multiple translations or just one? So you're just doing propositional logic on second test. One of the sentences is ambiguous. So for the ambiguous sentence, you have to provide 2 translations. For everything else, it's just one. I'm not telling you which one is ambiguous, but it's very similar to the one on assignment 3. Very similar. So are there any questions about either of these paraphrases? Okay, so in that case, I have some practice translations I want to do, and then I'll pass over some translations for you to do. F is very hard, but I will do these first. So each of these shows you something a little bit different. 15 and 16 look very similar, but there is a difference in how we translate them. So everything is hot or everything is cold, compared with everything is hot or cold. 17 is a little bit different because we're saying tall trees instead of just trees, or Ben is fond of tall things. And then 18 is a little bit interesting because we have a word like at least one. And we also have spooky ghost, so we have a description of a ghost. So let's start looking at 15. Everything is hot or everything is cold. Now, I want to illustrate something here. 3 universes, universe 1, universe 2, and universe 3. I want to think about when this sentence is true, just intuitively in English. Everything is hot or everything is cold. If I have a universe, and I'm going to use red here, where everything is hot, so everything is red, this should be true. So maybe I'll use a 1 here. What if I have a universe where literally everything is cold, so I use blue here? This should be true as well. But if I have a universe where I have some things that are hot and I have some things that are cold at the same time, and I say everything is hot or everything is cold, uh, this should be false, because when we say everything is hot or everything is cold, these are 2 statements that say, like, all is this thing or all is this thing. There's not really shared. So our translation should reflect that fact. So we should have 2 universal statements here, separated by an or. So we should say, like, for all x, something x, or for all y, something y. So 2 separate statements. We don't have to use y here. We could use x there as well. It doesn't matter, but they should be 2 separate statements. So for all x, we have to say everything is hot. Now, for the term everything literally means everything in the universe. So this is the case where we can just say, like, all x, hot x. This is fine. Like, everything in the universe is hot. So for all x, x is hot. That just means everything is hot. Or for all y, cold y. So for all y, y is cold. So the universal on its own just means everything. We don't need some sort of conditional here.
But is it okay to write for all x, x arrow hot x?
We can't just say x arrow hot x. If you wanted to do something with the arrow, you would have to do something like for all x, thing x, then hot x.
Okay.
You'd have to establish it as some sort of predicate, whether that predicate is a noun or, well, a noun of some sort. But if we want to talk about literally everything in our universe, then we just leave out that restrictor there. So that would be good enough. Let's think about this second sentence, though, and how it differs from the first one. If we say everything is hot or cold, so I'm going to keep the same universes here for the second sentence, but let's think about how the truth values would change. If I say everything is hot or cold, well, if everything is hot, I mean, this is true. Everything is hot or cold. I mean, everything is hot. This is true. We don't expect everything to be hot, but we're not lying here. If everything is cold, it's the same sort of deal. I mean, everything is still hot or cold. It just happens to be that everything is cold. But universe 3, where things are both hot and cold, now this is true for 16. Everything is hot or cold. Things are either hot or they're cold. They're both. So the way that we translate this is also different. So for all x, our conditions are a little bit different. For everything in our universe, x is either hot or x is cold. So the difference between these two is really the scope of our quantifier. So in 15, everything is hot or everything is cold. These are two separate quantifiers with different scopes. Or in 16, we're saying everything is hot or cold. So one quantifier is scoping over two different predicates here. So everything, every x is either hot or cold. So this is what gives us the difference in these truth values for these two situations. So I like this example in particular just because it shows one very subtle difference in translation. Okay, for 17, 17 has a proper name. This is something that we haven't really done recently, so you might have forgotten how to do this. And this is a common error that I see early on in translations. And we also have tall trees. So we have an adjective in our translation. So two things to deal with. So is fond of is going to act as a predicate here. So actually, I want to do this mechanically. So Ben is fond of tall trees. So how can we use our mechanical system to pull things out of the sentence when we don't have any quantifiers here like the or each? Well, I said before that sometimes there are hidden determiners. And with common nouns, sometimes you'll have hidden determiners like tall trees. You have plural marker here. So of tall trees. And there's this assumption that when you say things like is fond of tall trees, uh, is fond of dogs, likes seafood, that there's this underlying hidden universal quantifier, that there's this hidden word all here. So in predicate logic, we treat these common nouns missing our quantifiers here as if there's like this universal. So we think a little bit about this. Like if we say he's fond of dogs, we make this underlying assumption that it's not some particular dog, but rather it's all dogs. So this is just an assumption that we use for translation. So when we extract things, we can use the same method. So we can take all tall trees, and we can include that there as we pull it out, all tall trees X, pull that out, and say Ben is fond of X. So the reason we want to use the universal instead of the existential is because with the existential, that translates to some. And saying that Ben is fond of some tall tree would be a little bit further away from the truth rather than saying Ben is fond of all tall tree. Since normally if you say something like in real life, I don't know if I say, my friend really loves mathematics, it's more likely that that person enjoys all branches of mathematics or most branches rather than just a particular one. So it might not be a completely accurate translation, but in terms of what predicate logic can do, the best that it can do is translate with all rather than some. Okay, so with this, at this point, how do we break up all tall trees? Well, we're going to give each of these an index. So all X, tall X, trees X. So when we break things down and translate them, we're going to translate these piece by piece. So I need a little bit more room. I'll move this up to the Ben after I'm done. So for all X, tall X, trees X, so adjectives are going to get different predicates than nouns. So something can be tall, something can be tree. These are separate ideas, separate descriptions. And now what about Ben is fond of X? Well, is fond of is a predicate that does take two arguments. We know what the second one is, it's the object, but Ben is a subject. But again, with proper names, these are not variables, these are constants. So with proper names, we just put the proper name straight into the predicate. We don't do extraction here. We just leave the proper name as is in the predicate. These are people. These are individuals. For all X, tall X, trees X is fond of Ben X. Okay, so what do we do here? What do we do with the operators? Well, tall trees. If we want to say something like a tall tree, if X is a tall tree, X has the property of being tall and a tree. So we're grouping these together with the conjunction. So X is a tall tree, X is tall and X is a tree. So when we string adjectives together with their nouns, we use the conjunction for these. So even though we have the universal here, we're saying all tall trees. We're grouping these together as a unit. And then we'll use the arrow from tall trees to Ben being fond of those. So this is our restriction. This is our quantified expression. If X is a tall tree, then Ben is fond of X. Sorry, it's not, it's gonna fit here. So I want to put this up in the Ben position. We can get rid of that. I can put this over here. Okay. Sorry, there's a missing comma there. So for all X, if X is tall and X is a tree, then Ben is fond of X. I put an S after tree, but whether the S is there or not doesn't really matter. Tree X or trees X. Okay. Are there any questions about 17? Could it work the other way if Ben was in front or no? You mean like if Ben was on the left side and tall trees was on the right side? If you said for every X, if Ben is fond of X, then X is a tall tree. You'll run into issues with truth values. So things that, if Ben is fond of something that is not, if Ben is not fond of something and it's not a tall tree, you'll end up with things that are true. So if he's not fond of anything in the world, the sentence will be true. And that's not something you want in your translation. Okay, so the last one, just to make sure we get this in time, at least one spooky ghost scared Magdalena. So there's not really much new being added in this one, but there is the term at least one. So you might be thinking, hold on, how do we deal with this? But this is really just the existential some in disguise. So some means at least one. So what I want to say, at least two is different. So when you get higher, it behaves completely differently. But at least one just means some. Because when you say some cat is happy, that just means at least one cat is happy. So we could just paraphrase this as some spooky ghost scared Magdalena. So if we translate this piece by piece as we did before, this could be our X, some spooky ghost scared Magdalena. So some spooky ghost X scared Magdalena, and then we translate piece by piece. So to translate this, I'll go a little bit quicker, but it's the same process as before. So there is some X such that X is spooky. So spooky is an adjective. It gets its own predicate. Ghost is a noun. It gets its own predicate. And scared is a transitive verb. So X, the ghost, is the one doing the scaring. So that's the subject. And then Magdalena is the object, the one being scared. So here's the question is, which operators do we use? Well, spooky is describing ghost. So we'll use the conjunction to link those together because this is a noun phrase. But with the existential, we're also saying there's something that's a spooky ghost and that thing is scaring Magdalena. So we use the conjunction to connect spooky ghost and scaring Magdalena as well. So we're using the conjunction on everything here. So with the existential, it's a little bit more convenient. It's a little bit harder to make mistakes because we just use the conjunction with everything here. That also means that we can move things around inside the brackets, but I recommend not doing that just in case we add more quantifiers in and things get shuffled around. It's just a little bit easier to make mistakes when you start moving things around, if things get more complicated. So yeah, this was translating some sentences. So starting on Tuesday's class, we'll do some of the practice sentences. So these are a little bit more challenging in some cases, particularly E and F. But we can get some practice with those, and then we'll move on to assignment functions and finishing up the predicate logic section. So we're not doing every slide in this lecture, but we are finishing up to, let me see, this one, this one, this one, this one, this one, this one, and that is about it. So up to 24, maybe 25. So if you have any questions, you can stick around. But other than that, enjoy the weekend. The assignment and everything is due tomorrow night. And don't forget to finish the practice exercises by next Wednesday as well. I see most of you have done that for propositional logic and truth conditional meaning. But with truth conditional meaning as well, try those before you submit the assignment just to make sure that the trees are good. I recommend doing that. So enjoy the weekend, and I will see you Tuesday.